All right, we are in Building 27. Please introduce yourself.
My name is Mark Aggar. I am in the environmental sustainability team here at Microsoft.
Excellent.
I work on technology strategy, and in particular I work on what I'm calling greener IT.
Greener IT.
Greener IT. And that's really just a acknowledgement that green IT is a journey. There is no final destination.
Okay.
That you can say, okay, we're done, we're as fully green as we can be, let's say we're going to go focus on something else. It's really something that you have to continually focus on. There's always room for improvement.
So there's a reason that you're in pretty much the same building that our security teams are in, and Trustworthy Computing, because they have a similar initiative around security.
That's right.
It's a mission, it's never, it's a journey.
Exactly.
So Channel 9's audience, of course, are primarily developers and also people who are technically inclined and interested in how things work. Let's talk a little bit about the actual technology that you're going to tell us about today.
So essentially, Microsoft has been focusing on efficient computing for many years now, with the advent of Windows Power Management in, whatever it was, Windows 9X, I think, probably showed up first, and then got a lot stronger in Windows XP, and then a lot more deliberate focus on it in Windows Vista, and then most recently with Windows 7. Of course, our server products have, with Windows Server 2003, I think it was SP1, we turned on processor power management by default out of the box, and so you aren't having a bunch of servers sitting there throttled to use as much power as possible. They're actually balancing their the amount of performance they have with energy.
Excellent.
It's always a balance. And so what we've learned over the years, and particularly with the advent of Windows 7, is that there is a major role for application developers to play in ensuring that PCs and servers actually run efficiently. Really, an efficient system sort of lies at the intersection of the hardware, the work we've done with our hardware partners around processor power management and various other techniques. The operating system, obviously, because that's aware of the work that's going on, so we can actually work very well with the hardware to actually get the hardware into lower power states. But what's been neglected is the role that applications can play. And it's very simple for an application, probably inadvertently, to undermine all the work that the hardware ecosystem have done, as well as what Microsoft has done, and actually waste power while the system's running. And what's probably one of the most egregious cases is it just keeps the machine awake when it otherwise might be sleeping. There's a function in Windows 7 and Vista which was on by default called automatic sleep. So if you walk away from your PC and you don't put it to sleep, it will, after a period of time, go to sleep automatically, and you can come back and press the button and it will resume pretty quickly. Now there are ways for applications to request that the system does not go to sleep. And there are actually some very legitimate cases where you want that to happen. For instance, if you're sitting back watching video on your PC, you're not using the keyboard or mouse, the system will notice that that's not happening. And if the video player or the audio stack does not ask the system to stay awake, you'll be quite disappointed when the machine goes to sleep, like in the middle of the movie. And so there are legitimate reasons why you want applications to have some control over automatic sleep, and automatic sleep has a cousin around on the display as well, so that the application can request the display stays awake, which obviously is very important for video, things like video chats and everything else where you're not necessarily using the keyboard or mouse. Unfortunately though, with that power comes great responsibility, and a lot of applications inadvertently keep the either display and more often the system awake when it might otherwise have gone into automatic sleep mode. And so what we're trying to do is really highlight this as an issue to developers, and we've put a little bit of extra time and effort around our communications that we are making for what we're calling energy smart software.
Yes.
So we now have a new, sorry, actually an old site, but a new page and a new URL, Microsoft.com/EnergySmart, where developers can go and sort of learn the basics and then more advanced techniques for how to make their applications energy smart, so that they aren't keeping the machines awake, and then they're allowing the machine to actually go into low power modes even when it's active, and so we're actually exercising the capabilities of the hardware appropriately.
Excellent. Now, I mean, of course, developers are the ones writing, essentially, you know, they're the ones solving problems that require processing power and eating up memory and getting things hot. And we will be talking to your colleague on the Joule Meter project, which will help developers understand exactly how much code, how much energy their code is using. Perhaps they can refine it a little bit. But going back to the operating system, how much of the operating system's responsibility is it to ensure that, so let me step back, since an operating system abstracts hardware, why isn't the onus just on the operating system? So if I have an app like Office, for example, and Office has a tendency to go and make countless requests to the internet because it's so important to get your email. And so it'll move itself up the thread priority stack and all this stuff. They sort of figured out how to solve that problem out in Windows. But my question to you is simply, as a user, I might want to say, I don't care. I want to protect energy. I'm not at my computer. Then turn it off. Or maybe I'm going to get coffee or something. If I'm encoding a file, then please don't shut off. The operating system should be able to tell when the processors are pegged, or there's a lot of in-memory things going on. I'm not going to shut this off now. But if it's Office making requests to check a server or email, turn it off. And I know Office doesn't actually opt in to stay awake when Office is on, because mine goes to sleep all the time. But in the case of like Internet Explorer, that's not necessarily the case, at least, or it's the plugins that I'm using. That's the problem.
There are definitely some challenges. I think.
So that's my question, if I have one. Sorry.
So I think what you were trying to get at there.
There you go.
Was it's really about intent. And unfortunately, the operating system, as smart as it is not always able to divine the intent of the application. And what may be coming, or what why it may need to stay awake. So, for instance, if you are uploading photos to Facebook or Flickr or wherever, that may take a long time depending on your upload bandwidth. Now, an application by default isn't going to, or the operating system by default isn't going to say, I know you're uploading a lot of data, and that it's probably a good idea to let that task finish before I go to sleep. Because, I don't know, you may be just drizzling data up for all it knows. It doesn't know what the intent of the application is or the overall scenario. So it's really up to the application to be explicit and say, no, I really want, during this time period, for the machine to stay awake. And then when I've done, then I'm going to drop that availability request, and then the system can go to sleep on its own if it's awake. There's a similar feature, actually, bit of a digression, but on Xbox, where if you're, it's the opposite to what I just described, where if you're downloading code, programs or games, demos, or whatever else, you can turn the Xbox off after you've initiated the download. The Xbox actually doesn't go off. It actually stays on. It turns off the display and the keyboard, and for all intents and purposes, it looks like it's off, except for the flashing green ring goes on and off just to let you know, well, I'm really still on. I'm currently downloading, and then when the download is finished, the computer goes off. So it's it's almost the same scenario in reverse.
Interesting.
But the system has to be designed with that in mind. The OS can't just magically figure that out, that's what you want.
And so, I mean, a lot of times the only thing I would say is, when Windows has traditionally given developers a lot of flexibility to override certain behavior for special cases. Let's talk about, and this is sort of why exactly you're doing this project, right? To educate us into how to think about being more of a democratic player in what's going on the operating system, and not to waste too much energy. But that said, developers of applications don't always know how their applications are going to be used.
Exactly.
And so it really, eventually, like security, comes back ultimately to the end user, right? So what I mean by that, is there an API where an end user can, I write an application that plugs into some framework. Users then say, for this application, I want to enable this capability, and the application, of course, has to have some sort of mechanism where it interoperates with the user to get its initial response. Say, yes, you can turn me off during these types of operation. Talk to me about the granularity of this.
Yeah. So I'm going to disagree with you a little bit.
Good.
In the sense that the applications should be able to be conscious during the design process about what tasks and activities need to finish to avoid, say, a data loss scenario. So, for instance, if I'm recording TV, having the computer go to sleep during the middle of the program because no one was using the computer is kind of a dumb idea, right?
Yes.
So there's many scenarios. Now, there are a lot of cases, though, where the situation is quite subtle. So I've seen instances where the computer stays awake because a dialog box hasn't cleared and the availability request was only cleared once the OK button was pressed. So that's just a really simple bug. The availability request needs to happen before the OK button is pressed. And so when the computer resumes, you say, oh, my download finished, I hit OK, and you're none the wiser that the computer even necessarily went to sleep. As long as your download is finished and is intact, then everything is okay. Certainly users have the ability at a gross system level to disable sleep and disable power management, but we're really trying to avoid situations where they feel compelled to do that, because it's our experience. In our experience, we know that users, once they change it once, they invariably forget to change it back. And so what we really want is, out of the box, Windows 7 ships with a 30-minute system sleep interval. We really want users to, for the most part, just leave it like that, or even make it more aggressive. We don't want users to have to come back and say, oh, well, for this particular DVD encoding task, I need to change the system sleep timeout, because if I don't, then I'm going to turn my disk into a coaster because the burn process stopped halfway through.
Sure.
So I think I haven't actually run into a situation yet where an application developer couldn't have figured out when to use an availability request on the system or on the display, given the scenario in which the applications are being used. Now, there's what we haven't talked about yet, and I'll take this opportunity to talk about it, is that there's a number of tools that allow both end users, and particularly enthusiasts and IT pros, and developers to determine what is keeping the machine awake or what's keeping the display awake. So in Windows 7, and there's an interesting backstory to this into how this whole thing started for me and why I'm sitting here with you today. So in Windows 7, when it was in beta, as I was sort of talking with the Windows kernel guys, and was under the impression, just from what I'd heard about the Windows 7 planning process, which I was involved with, that power management was going to be like so much better in Windows 7, and systems were going to sleep reliably, all this sort of classic marketing stuff. And so I'm running Windows 7 on my machines in this office, and I'm noticing that my machines aren't going to sleep. It's like, well, I thought this was one of the focus areas. And so I talked to the kernel guys and say, well, run powercfg/requests. So powercfg has been available in in Vista, and I think even beyond that. But we add a new capability, the /requests flag, which will show you the outstanding availability requests on the system. So it's like, oh, okay, so availability requests are the things that keep the machine awake. So you run this tool, and it showed me that there was a kernel device driver, because this was in beta, that was keeping the machine awake. I said, okay, well, that's not particularly useful. What's this kernel device driver? Well, it turns out that this kernel device driver was the audio stack, and actually Windows, before we shipped, has actually been, the audio stack has been instrumented in a way so it actually says, I'm the audio stack and I'm keeping you awake. So now I know that there's an application that's using audio that's keeping the machine awake. Well, there's no audio playing on my machine when this is occurring, so it's sort of a matter of trial and error to find out, well, what application has the audio stack open and is sending data to the audio stack where the audio stack thinks I should keep the machine awake. Well, it turned out that it was Adobe Flash Player that was streaming silence to the audio stack. The audio stack, being a good citizen, is keeping the machine awake, because obviously you don't want your machine to go to sleep while you're listening to music in the background.
Weird.
And so it was like this powercfg command, which was like, wow, so this is a problem. And then of course I subsequently started noticing lots of other issues, and it was like, there's a real problem in the ecosystem here.